Welcome back to Introduction to Symbolic Logic. This is lecture 4. Today we are going to start out by introducing a few more semantic concepts. In particular, 3 additional semantic concepts, which are joint satisfiability, tautological equivalence, and tautological entailment. In a second step, we are going to discuss how we can use truth tables to test for joint satisfiability, tautological equivalence, and tautological entailment. We are going to see that these truth tables can become very complex and big. And so in a third step, we are going to discuss how you can simplify this process and use partial truth tables to answer some questions. And then finally, in the fourth part of this lecture, we are going to breach a new topic and talk about expressive completeness. Okay, we talked about a few semantic concepts yesterday. We discussed tautologies, contradictions, and truth table contingent sentences. And now we are going to build on this and add a few more semantic concepts. And the basic difference to the concepts that you have already heard about is that we are now talking about the properties of multiple sentences at a time, or in other words, about the relationships between multiple sentences, rather than just the properties of individual sentences. The first new concept is the concept of joint satisfiability. 2 or more sentences are jointly satisfiable if and only if there is a valuation on which they both or all are true. Now, that means that the joint truth table of jointly satisfiable sentences contains a row in which each of these sentences exhibits a T in the column under the main connective. So for example, the 2 sentences A or B and A and B are jointly satisfiable. And you can verify this assertion by looking at the first row of the truth table exhibited at the bottom of that slide. So you see that when both A and B are true, A or B is true, given that the truth of a disjunction requires that at least one of the 2 disjuncts is true, and A and B is also true, given that a conjunction is true if and only if both conjuncts are true. So there is a valuation represented in the first row of this truth table on which both sentences are true, and that means that they are jointly satisfiable. Let's talk about tautological equivalence. 2 or more sentences are tautologically equivalent if and only if they have the same truth value on every valuation. What that means is that in their joint truth table, tautologically equivalent sentences exhibit the same pattern of T's and F's in the column under the main connective. So for example, the 2 sentences A or B, and it's not the case that not A and not B are tautologically equivalent. To verify this, just look at this truth table exhibited at the bottom of the slide. We see that A or B is true when both A and B are true. It's true when A is true and B is false. It's also true when A is false and B is true. And the only case in which A or B is false is when both A and B are false. And then when you look at the rightmost column, you will observe that the same pattern applies to the sentence, it's not the case that not A and not B. The main connective of this sentence is the first negation sign that negates the conjunction inside the parentheses. And in the column under the negation sign, you will see a pattern of T, 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 and F, which is exactly the pattern that we see under the disjunction. And so again, that means that these two sentences exhibit the same pattern of T's and F's in the column under their main connective, and that means that they are tautologically equivalent. Finally, let's talk about entailment. A set of sentences, A, B, and so on and so forth, entails a sentence C if every valuation on which all of A, B, and so on and so forth are true is also a valuation on which C is true. Now that means that the joint truth table of A, B, and so on and so forth and C is such that every row that displays a T under each of the main connectives of A, B, and so on and so forth is a row that also displays a T under the main connective of C. Now, in that case, we also say that the argument from premises A, B, and so on and so forth to conclusion C is tautologically valid. So a tautologically valid argument is such that the premises of the argument entail the conclusion. So let's look at an example to illustrate this. This is a truth table that you have already seen. It is the joint truth table for the two sentences A or B and A and B. And you can observe that A and B entails A or B, but A or B does not entail A and B. Why is that? Well, let's first look at the rightmost column under the conjunction A and B. There you will see that A and B is true in just one case, displayed in the first row of the truth table. So A and B is true if and only if both A and B are true. And now when both A and B are true, the disjunction A or B is also true. And so that means that on every valuation on which the conjunction A and B is true, the disjunction A or B is also true. And that means that the conjunction entails the disjunction. Now, the reverse does not hold. The disjunction A or B does not entail the conjunction A and B. Why is that? Well, let's look, for example, at the second row of this truth table. In the second row, you see that the disjunction A or B is true, given that the first disjunct A is true, but the conjunction A and B is false, because the second conjunct B is false. And so that means that there is a valuation on which the disjunction A or B is true, but the conjunction A and B is false. And that means that the disjunction does not entail the conjunction.